Okay, let's continue our discussion. Aflatoxins produced by mold and on peanut crops in Virginia must be monitored. A sample of 64 batches of peanuts reveals levels of 24.17 ppm on average. Here's the average. X bar equals to 24.7 with a variance of 4.25. So S squared equals to 4.25. Test the hypothesis that sigma squared equals to 4.2, and the alternative is sigma squared doesn't equal to that. So from the question we know hypothesis is sigma squared equals to 4.2, and the alternative hypothesis is sigma squared doesn't equal to 4.2. Okay, then we need to get the formula to solve this problem. Test single variance. So in this question, we need to test the statistic, this one. Then we have two on left and right side. We have two rejection region. So x 0 equals to n minus 1 s squared divided by sigma squared. So that's 63 times 4.25 divided by 4.2 equals to 63.75. Okay, so we need to compare it with this one and this one. So x0 x. Oh, we need to use the p-value in my conclusion, so we can just get this p-value of this. So p-value equals to 2 times, that should be x squared greater than x0 squared. So because it's two sides, so there are 2 times. We use a calculator for chi-square. So our degree of freedom is 63, and the chi-square is 63.75. So this is our p-value. No, this is the one side of the region. So it's 2 times 0.4499 equals to 0.8998. It's less than 0.05. So we can conclude failed to reject H0. Okay, that's the first question about the single variance. Compare single variance with the value. And let's take a look at that. An experiment was conducted to compare the alcohol content of soy sauce on 2 different product lines. Production was monitored 8 times a day. The data are shown here. So from data I get the mean and the variance already. Assume both populations are normal. It is suspected that production line 1 is not producing as consistent as production 2. So we get the null hypothesis is sigma 1 equal to sigma 2, and the alternative is sigma 1 doesn't equal to sigma 2. So let's take a look how we solve this problem. So in this document, the formula was given. So f0 is this. So we need to compare the f0 with those two sides, this one and this one, okay, because it's unequal. So f0 equals to s1 squared divided by s2 squared. So we'll just put the number in, 0.003055 divided by 0.000155 equals to This is 197097. Okay. So also we need to use the p-value in our conclusion. So p-value equals to 2 times probability f greater than f0. Okay, because it's 2 sides, so there's this equals to. Also, I use the online calculator for my calculation. F distribution, degree of freedom. Both degree of freedom is 8 minus 1, so it's 7. No, 7. Probability, we don't have the probability, we want the probability. The f value is 19 something. 19. Here. We get the result. Because this is f less or equal to this value. So what we want is 1 minus 0.9996. So it's 2 times 1 minus 0.9996. So equals to 0.0008. This is less than 0.05. So we can conclude reject the null hypothesis. So that's the way we compare to variance. Okay. So let's take a look at this one. A die is tossed 180 times with the following results. So here's our result here. Is this a balanced die? Use a 0.01 level of significance. So a balanced die means for the number from 1 to 6, the distribution should follow a uniform distribution. So which means for x is 1, 2, 3, 4, 5, 6, and this is our objective value is 28, 36, 30, 27, 23. So expected object is, this is 100, is 180 times over 1 over 6 equals to 30. So this 30, 30, 30, 30. So we're gonna use the formula, this one, x squared equals to OI objective minus expected I divided by expected I squared. So in our case, this x squared equals to minus 2 squared divided by 30 plus 6 squared divided by 30 plus 0 here, plus minus 3 squared divided by 30 plus minus 7 squared divided by 30 equals to 4.4666. So this is our x result. And what we need to do is to compare this value with 2 sides, because our hypothesis is this die follow uniform distribution, and the alternative is doesn't follow uniform. Okay, so it's a 2-sided problem. So in that case, we need to find the x squared 0.01 divided by 2. Then the degree of freedom is 6 minus 1. 6 minus 1. So this equals to 16.750, and we also need to get this one. This equals to 0.412, because this 4.4666 fall between these two, so we conclude failed to reject H0. So which means this die follows uniform distribution. So this is a balanced die. Okay, thanks for watching. That's all for today.